Welcome you to our survey of technical systems which MediaNet uses for realization of integrated designs. The entire system is based on matching modules, all of which are produced and programmed by MediaNet. All system modules are designed to operate with one another with maximum efficiency and loss-free to ensure an overall system which is completely capable of online maintenance. Instead of a simple standard bus, we use a bus structure with media control, which we designed specifically for this application and which is capable of easily controlling and processing comprehensive and complex events. The technical features of the components used are optimized for maximum utility, even though the details are not obvious to users under normal circumstances. Users are presented with a logical view of the system. This eliminates any necessity for users to study the technical details. For purposes of explanation, the following categories are first defined: disciplines, contexts, scenes, operating modes, and scenarios. The discipline indicates what is to be controlled, for example, light, music, air conditioning and heating, access, features relevant for safety, or special features depending on the object. Each discipline is described as a context in a certain room or area. This therefore indicates where something is to be controlled. Contexts can overlap partially or completely. For example, a number of sub-areas in the living room make up the entire living room. A number of contexts can be combined to one single operation, for example by opening a sliding door. Contexts allow settings to be saved in so-called scenes. These can consist of light moods for a certain area or certain utilization, for example. The scene also indicates how something is to be controlled and can be called at any time by simply pressing a button. Using the light as an example, all light sources associated with the context are switched to the set values when a scene is called. But who is authorized to change anything at all? In the private sphere, these include the residents, family members, and perhaps guests. For commercial applications, it is, for example, necessary to differentiate between employees and other authorized groups of persons. Control is also possible by the system itself. In such cases, control is based on statuses, sensor values, and operating modes. Transfer of settings from one room to another is called escalation. The extent of escalation can be determined freely, for example, from the bedroom to the hallway, to the story, to the staircase, and finally to the whole building. Escalation is possible by simply holding down a key on your keypad for a longer period of time. Various disciplines, such as light settings, music selections, and temperature values, for example, can be combined in so-called scenarios. These can be activated automatically or manually by pressing a button. It is therefore possible to create a new atmosphere to match the time of day, an event, or your momentary mood simply by pressing a button. Operating modes can also be realized on an overlapping basis to change the characteristics of certain areas or even the entire building. For example, it is possible to define party settings or special settings for when you are absent. With a touch of a button, your estate changes into a discotheque or a high-security tract and even adapts to the season. One of the many special features of the MediaNet system is the keypad lock. With your personal code, you can lock your control pad to prevent unintentional use by children or guests. The technical backbone of the MediaNet system is the SCLAN bus system. SCLAN stands for Site Control Local Area Network and was developed by MediaNet itself. All SCLAN pads and control nodes are connected with one another by a specially designed high-quality bus cable. The SCLAN bus cable also provides for power supply to all components. The power supply for the SCLAN components is decentralized and redundant, using high-quality MediaNet power packs. If desired, a fail-safe device for power failures can also be integrated for maximum operational reliability. When installing, it is only necessary to route the SCLAN bus so that all control pads and control nodes can be connected. A special sequence is not required. Then it is only necessary to connect the loads to be controlled and the sensors to the control nodes. The focus is on practical installation aspects, not system requirements. During mechanical installation, it is not necessary to consider the contexts and interrelationships to be created, nor is local reprogramming required. Any desired communication link is sufficient. All features can then be downloaded into the individual components by MediaNet by remote control over the bus. This also applies for complete firmware updates and any other type of service to the SCLAN nodes. If desired, modifications are even possible via the internet without even entering the building.
MediaNet, good afternoon. Can we help you?
Good afternoon. Mrs. Miller calling. I don't like the light in my bathroom anymore. The ceiling is too bright when I take a bath.
No problem, Mrs. Miller. I'm now switching the different scenes and you tell me in which one the light should be changed.
Stop. In this one, please.
Tell me, please, if you want to change the ceiling lamp which is flashing now.
Oh, yes. That's the one.
Okay, Mrs. Miller. Now I'm going to reduce the brightness of the lamp and you tell me when it's to your satisfaction.
Stop. Just got it fine.
Alright, I have stored the new setting. In case of any further changes, we can always proceed the same way as done.
Great. Many thanks for your quick help.
It's a pleasure. Bye-bye, Mrs. Miller.
The system features are realized by the software in the SCLAN nodes, which cooperate with one another. In the event of failure of individual components, the remaining components continue to fulfill their function, ensuring stable, failure-tolerant system operation. There are no central nodes whose failure would disable the entire system. After replacement, the SCLAN nodes resynchronize themselves automatically, including the time and date settings. We use our own media server, optimized for our system for supplementary features and control via the web surface. This server also provides music and video. Control of the system is possible in various ways. The most elegant and versatile control is the SCLAN keypad, available in various models and design versions. It is available in solid metal or chrome-plated, gold-plated, hammered with enamel finish, in glass or natural stone to fit harmoniously with all surroundings. The color of the illuminated keys can be changed to match the room furnishings, mood or season. The keypad is initially arranged in 4 categories: light, music, special features, and air conditioning and heating. These are repeated throughout the entire house for each room. Each category is also called a discipline. Each discipline has a number of scenes which can be set for you, such as light moods, music, or air conditioning and heating settings. The number of possible scenes is unlimited. The individual values for a scene can be changed temporarily with the plus-minus switch, or permanently in the extremely simple setup mode. For example, the music volume, the light intensity, or the temperature. The large middle button switches everything off or everything on at once. The change in the color of a key is not a reaction to pressing the key, but rather is feedback from the responsible control node confirming the operation. This feedback can always be seen on all keypads assigned the function being confirmed. All functions can also be controlled with the remote control, a cell phone, PDA, or PC in combination with the web surface. The keypad can even serve as an emergency light with its illuminated keys and an installed emergency bus power supply. It is also possible to connect certain sensors or actuators to the control pad directly. They can be included in the control contexts in the same manner as if they were connected directly to a control node. A number of processors operate together in the SCLAN nodes to exhaust all possibilities. Control over a computer with a network link is also possible, however not necessary. The SCLAN system itself does not require either PC or servers for proper operation. LPC, local peripheral controller type SCLAN nodes, are the primary devices used for controlling of building equipment. These communicate via the bus with their partner nodes and allow connection of actuator and sensor modules, which can simply be connected in series. The modules are supplied with power by the LPC, so that it is only necessary to connect the loads or signal sources. The loads can be connected to the actuators, remote switches and other signal sources to the sensors. A serial port on the LPC serves for communication with servers, modems or other equipment. An integrated LPC also controls the multi-room audio router, whose special design provides top-notch music fidelity throughout the entire